Welcome back, guys. So today we are going to look at an OOM error, and this is something that you will always see in Kubernetes, mostly because either the developers didn't write the code properly or we didn't do our job properly. So I have two scripts over here. One is the script.yaml, which is a config map. So I will do a k-apply -f script.yaml, and this is going to create a config map. And the second one is the pod. So k-apply -f pod.yaml, and we have the pod as well. So if I do a kget pods, you can see that it is going into a crash loop back off. And if you guys don't know about -w, it's for watch. So it will keep checking the pod until the status changes, and then it would print it out every time the status is changed. So it's still in OOMKilled, so it is not going to print anymore. And then it comes back to crash loop back off, and then it will again go into running, and it will get an OOMKilled. So let's do a logs on this pod to see why it is. As soon as the container dies, we don't have the logs because the container logs are gone when the container goes away. But in this case, we don't have the logs. We can do a kget events, and it is going to say that node status 1 is, oh, this is from 15 days ago. So forget about this. The ones that we need to look at are these ones. So we have the custom Python slim image on the pod, and it is going into back of restarting. So as you can see, the events are also not helpful. So in this situation, if we describe the pod, we will see the events at the bottom. But for OOM, the events is basically Kubernetes telling what is happening. OOM is related to the container. So we need to go into container. So here are our containers for the pod, and we have our Python worker, which has the 3.9 slim image. And here you can see terminated, and it has been terminated for OOM. 137 is the exit code. So 0 to 127 are the error codes for any application level errors. And going from 128 onwards, it is handled by the Linux kernel. In this case, we have 137. So if I do a 128 minus 137 minus 128, that is equal to 9. 9 is the kill command for Linux kernel. This is Linux kernel telling the container that you need to exit ASAP, so I'm going to kill you, because the memory that the Linux kernel allocated to the container is way less than what the container is working with. And the reason I know this is because my script, if I go into my script, I have a script which basically needs 200 MI of memory. So I am writing a script which needs 200 MI of memory, but in our container, we are telling the container that it should only limit the memory until 100 MI. So what is happening is the script starts running, it needs 200 MI, the Kubernetes hits the limit of 100, and the Linux kernel is like, okay, you cannot run this because you have 100 MI and you need 200. I cannot let you run because I can only give you 100 MI. So I'm going to kill you. And that's how it kills the process. So what is the fix for this? One of the fixes, you can write your application in such a way that it takes less memory or it consumes less memory. The second way is you should always know what the script is doing. So if you know that the script needs 200 MI of memory, there is no reason for us to actually give it 100 MI of limit. So it is, this pod is requesting 50 MI, it needs 200, and we are telling that the pod can only use up until 100 MI. So we are going to modify this to memory request of 200, and then we are going to limit it at 300 MI. So if I save and quit and k get pods, delete pod, custom memory hog, k apply -f custom memory pod.yaml. And if I do a k get pods minus w, you will see now it won't crash. And the reason it won't crash because we gave it 200 MI of memory and it needs 200 MI. So here it needs 200 and we gave it 200. And then we are telling that go up until 300, but not beyond 300. So if I do a kget pods, you have it back running. So most of the times when a process is OOMed, which is out of memory, you always have to come back to the request and limits for the container. And you also have another concept called as request quota and memory quota for the namespace. We can look into that later on. But I think this is it for this video, guys. I hope this was helpful. Always remember 0 to 127 error codes are for the application, and going forward from 128, it would be for Linux kernel. 137 is the most common one that you will see, which would be CKAD 9, which means that the Linux kernel just shuts it down. It doesn't wait for anything else. The other ones that are there is 143, which is 15, I think, which basically tells the Linux kernel tells the application, hey, you have to exit, so exit gracefully. But I think that is it for this video, guys, and I'll see you guys in the next one.